In this lesson we're going to look at angles formed inside circles, and one of the most important concepts in this is to spot isosceles triangles. Now, an isosceles triangle is a triangle where two of the sides are exactly the same size and two of the angles are exactly the same size. A triangle like this, these two sides are exactly the same, and these two angles at the bottom are exactly the same. That's the idea behind an isosceles triangle. Now, they are created inside a circle from radii, or two radiuses. So we have a radius here and a radius there. That creates the isosceles triangle, and the angles on the outside, i.e. closest to the circumference, are exactly the same. It doesn't have to be in this setup here. I could take a radius here and then another radius here, and if I join these two up, then I have an isosceles triangle again. That side is exactly the same as that side because that's a radius and that's a radius, and this angle here is exactly the same as that angle here. This new line that we've created here is called a chord. A chord is a line that touches one side of the circle, joins up to the other, but it doesn't go through the centre point, or it would be called a diameter. Here's another chord here. Okay, so any line through a circle, I'll just make another one here, any line through a circle that doesn't go through the centre point and touches both sides, for example this line here, is called a chord. This line here is also a chord. This line here is also a chord. As long as it doesn't go through the centre, then it would be called a diameter. Okay, before we do some examples, it's important to understand some basic angle facts and remind ourselves of those. Angles in a triangle add up to 180 degrees, so if you know two angles, you can subtract from 180 to get the third. Look out for equilateral triangles. All sides are the same size, and all angles in an equilateral triangle are exactly the same. They're all going to be 60 because 180 divided by 3 is 60. Vertically opposite angles are equal. They happen when two straight lines cross at a point. So these two sides of the angles are the same, and these two angles are exactly the same. Look out for angles that make 90 degrees and that are split into two. These are called complementary angles. So if I know the 70 here and I knew this was a right angle, I could do 90 take away 70 to get the 20. And also supplementary angles, really important, and particularly the work we're going to do in a minute. When you split supplementary angles in two, the two angles come to 180 degrees. So if I knew the 130 and I was trying to find this, I would do 180 take away 130. And finally, Z-shape angles, they happen when two lines are parallel to each other, signified by these wee two arrows, and we take a kind of diagonal line through it. So this angle here, this red one, is exactly the same as that one there. And that one there is exactly the same as that one there. Right, let's have a look at how to do this. So this first example, find the missing angles in each of these. So this here is an isosceles triangle. That's a radius, and that's a radius. Okay, and it's the two angles on the outside that are the same. That angle there is the same as that angle there, the ones near the circumference. Which means that that top angle there is 34 degrees. So that's 34. Just try and write this with the mouse. Now, because I've got that angle there, and I know it's 34 degrees, then I can add two 34s to work out this angle here. So 34 and 34 comes to 68, and if I do 180 take away 68, I'm going to get 112. So this angle in here is 112 when I'm finished. Okay, moving on to this second one here. So again, if we try and spot the isosceles triangle, that's a radius, which means these two angles here, that one and that one, the ones on the outside near the circumference, are the same. So this one's going to be 47. Now again, if I double 47 and then I take away from 180, I'm going to get this third angle at the bottom here. So 47 and 47, what's that, 94? So if I do 180 take away 94, I'm going to get 86. That's 86 there. Okay, now the last angle to get is this one here, and I can see a straight line going straight along here, split into two, split into that and that. So if I do 180 take away 86, I'm going to get this angle here. 180 take away 86 is 94. Okay, let's look at this last example. So again, try and spot isosceles triangles. Straight away I'm thinking there's a radius, there's a radius. So this is an isosceles triangle, which means that that there is going to be 21. Okay, so if that's 21 degrees, I can again work out this third angle in the triangle. If I add the two 21s, I get 42. If I take them away from 180, that means that's 138. Now, looking at this triangle at the top, again, look for the radius. There's a radius. There's a radius. Now, this line means that these two are exactly the same size. So that must be the same size as the radius as well. So I must have an isosceles, an equilateral triangle there. So an equilateral triangle has all of its angles the same, and they're all 60. 180 divided by 3. So that's going to be 60. It's hard to draw with a mouse, but that's going to be 60, and that's going to be 60 degrees, and I'm finished.